Welcome back to Shibe's chemistry classes. Today we have to study coordinate bond, and this is the fourth video, and three videos we have already completed, in which we have covered electrovalent bond, covalent bond, and structure of covalent bond. And this is the fourth and the last video, and here today we are going to study about the coordinate bonds. Coordinate bond is also called dative bond. See, I will explain you this with the help of an example. And if we take example, then the thing will become more clear to you. So let's take the example of formation of ammonium ion, NH4 ion. And we know that nitrogen atomic number is 7, configuration is 2, 5, and hydrogen atomic number is 1 and the configuration is 1. So before coming to ammonium ion, we should know the structure of ammonia. Ammonia is NH3. Ammonia is NH3. Let's draw the structure of ammonia. Here nitrogen has 5 electrons in its outer shell, of which 3 electrons are paired by 3 hydrogen electrons. See, 3 hydrogen atom pair these 3 electrons of ammonia, of nitrogen in ammonia, and 1 pair of electron is left. And you can see 1 pair of electron is left here in nitrogen, and this pair of electron is called lone pair. Why it is called lone pair? Because it is not paired with any other atom. It is alone. It is standing alone over here. So that is why it is called lone pair. Lone pair. So what is lone pair? The pair of electron that is not shared by any other atom. So this lone pair, so nitrogen is capable of donating this lone pair electron to some other atom which needs this electron. So what will happen when the hydrogen ion, this is H plus, we know the atomic number of hydrogen is 1, that means it has 1 electron, so it needs 1 more electron to complete the duplet to get the electronic configuration similar to helium. But what happens in case of H plus? Here you can see plus sign, and a plus sign means this hydrogen is not having any electron in it. It is having 0 electron. That is why its net effect is of positive charge. And so when this hydrogen ion approaches this ammonia molecule, what will happen? This nitrogen having 1 extra lone pair of electron donates this electron to hydrogen ion. This is hydrogen ion. This hydrogen is having positive charge, that is why we are saying hydrogen ion. This is not hydrogen atom. Hydrogen atom is this H. Okay, so this is hydrogen ion. So what will happen? This nitrogen having 1 lone pair of electron is donated to this hydrogen ion, and it will form a coordinate bond. Means the sharing of electron is taking place here, but the sharing is done entirely by one combining atom. In covalent bond, what we have studied, that mutual sharing is taking place between both the combining atom. But in case of coordinate bond, the shared pair of electron is contributed entirely by one atom, but it is shared by both. Even if it is contributing this electron to hydrogen ion, but it is shared between nitrogen and hydrogen as well, then only its octet will be complete. So you will get a structure like this. This arrow shows that it is a coordinate bond. This is the way of showing coordinate bond. And a bond we used to show with a dash, but coordinate bond, a dash with an arrow. So if arrow is pointing towards the other atom which is accepting the electron, lone pair of electron. So here nitrogen is acting as a donor and hydrogen is acting as a acceptor. So what will happen? Nitrogen is also satisfied with 8 electron and hydrogen is satisfied with 2 electron. So in this way, ammonia ion is formed, ammonium ion. So once the this thing happened, all the 4 NH, all the 4 NH bond become identical. And after the formation of ammonium ion, what will happen? All the four hydrogen you can see, that means 4 bond it has, 3 covalent bond and 1 coordinate bond. But we can't say in the compound, we can't distinguish that which one is a coordinate bond and which one is covalent bond, because we can't see the bond over there. No? It is a whole compound. So we can say that once the bond is formed, it becomes, all the 4 bond become identical. So the correct way of representing this ammonium ion is, we keep this inside a bracket and put a plus over here. Clear? So this is the formation of ammonium ion. Now how we will define the coordinate bond? From this example, how we will define coordinate bond? कोऑर्डिनेट बॉन्ड को डिफाइन कैसे करेंगे हम? The bond formed between two atoms. The bond formed between two atoms by sharing of electron pair. Bond formation is taking place what? Between two atoms by sharing of an electron pair, contributed entirely by a single atom to the other atom, but shared between the two, or shared between both. Let me write over here. The bond formed between two atoms by the sharing of a pair of electron contributed entirely by a single atom and but shared by both. See, sharing is happening between both the atoms. So then only valency will be satisfied. See, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is hydrogen, this is electron of hydrogen. How many electrons I have made here? So cross represent the electron of hydrogen. 1, 2, 3. So how can you say? This coordinate bond is the bond formed between two atoms by the sharing of a pair of electrons contributed entirely by a single atom but shared by both. So this is coordinate bond. So I think this is more clear to you with the help of this example. One more example is there in your syllabus, that is a formation of hydronium ion. You can note it down in your notebook. Next we will see the formation of hydronium ion. Hydronium H3O plus ion. So before that, first I'll explain you how this H plus is formed. In the previous example also we have seen this H plus. What we call it as hydrogen ion. So how this hydrogen ion is formed? So see what happens when an acid is added to water. Acid, you know, HCl is acid, that is hydrochloric acid, HNO3 is nitric acid, H2SO4 is sulfuric acid. So what happens when an acid is added to water? Every time when we do the dilution, acid is added to water instead of water being added to acid. ठीक है, we always add acid little by little to water. So what will happen when acid, say HCl, is added to water? We know that HCl is a polar covalent compound, and H2O is also a polar covalent compound. That means both these compounds are having poles. And so what happened? Both are polar compounds. When this is added to this thing, the strong dipole-dipole interaction, the strong dipole-dipole interaction result in the removal of H plus from HCl. What will happen? This H plus is removed from Cl. Cl is more electronegative than hydrogen. That we know chlorine is more electronegative. So what will happen? It will pull the shared pair of electron. As a result, the electron of hydrogen also go along with chlorine. Structure is like this. 7. We have 7 electrons in the valence shell of chlorine and 1 in hydrogen. So after combination, after the formation of covalent compound or covalent bonding, this electron are shared between two. Mutual sharing is taking place. But chlorine, being more electronegative, takes away the electron of hydrogen as well. So hydrogen is left with nothing. So that is why it develops a positive charge. So due to dipole-dipole interaction, this chlorine takes away the electron of hydrogen, and hydrogen develops a positive charge and chlorine a negative charge. So the species that is formed over here, this is hydrogen ion, but this species is extremely unstable. It don't exist. It don't exist. So what happened? Immediately it combined with the another water molecule. So what will happen? This H plus combine with the water molecule and form H3O, and this H3O is called hydronium ion. Alright, since H3O is called hydronium, being an extremely unstable species, this H plus immediately add on to another water molecule. How it is getting added to water molecule? So for that we have to see the structure of water molecule. Water molecule, it is formed up of 3 atoms, 2 hydrogen and 1 oxygen. Oxygen atomic number is 8, configuration 2, 6, hydrogen is 1. So you can see that it is having 2 electron short to complete the octet. So from the structure of water molecule, you can see that this oxygen is having 2 lone pairs of electron. And so it is ready to donate these 2 lone pairs of electron to another atom which needs it. So here in this case, who needs this lone pair? H plus needs the lone pair, because it's not having any electron, 0 electron, highly unstable. And so what happened? This H plus immediately come and ask for this lone pair of electron from the another water molecule. So this oxygen will give a lone pair to hydrogen ion. And a coordinate bond is formed. So this is hydronium ion. So once this bond is formed, all the 3 bonds become identical. So we represent it as H3O inside bracket with a plus sign, because we don't know to which hydrogen this plus sign exists. So to better we show it together, we put it inside a bracket and put a plus over here. Okay, so this is the way how hydronium ion is formed. So I think now coordinate bond is clear to you. So two conditions are necessary for the formation of coordinate bond. What are those two conditions? Conditions for the formation of coordinate bond. What are the two conditions needed for the formation of coordinate bond? First, one of the combining atoms must have a lone pair of electron. It must have a lone pair of electron. Out of the two combining atom, one of the combining atom should have a lone pair of electron. Then only it will donate it to the other atom. And the second condition is another combining atom should have a lone pair short, and a short of a lone pair of electron to complete its octet or duplet. Another atom should be short of a pair of electron. See, definitions and all you will get from your book, because all those things are written very clearly in your book. I'm just writing to explain you. Okay. So this is about coordinate bond. Let me check if anything is left. Okay, this much is there. So I hope this is clear to everyone. And in the next video, we are going to start the third chapter. Till then, bye-bye.